Before we look into how video compression works, I want to take a little bit of time to explore why video compression is even necessary in the first place. And so, what I've got here are a couple of um, image files. These are just screen captures from the show The Queen's Gambit, and I've got one as a PNG and one as a JPEG image, and I want to look at how this would translate to a movie or a video file. And if you think about it, a video file is actually just a sequence of images being swapped out really, really quickly. So in a typical movie, a typical video you watch, it's going to be about 30 different frames per second, right? So 30 times a second, the image is actually going to change. And so these two images I have, the PNG file is 1920 by 1080, and the JPEG file is also 1920 by 1080. I picked those dimensions because those are the standard resolutions for an HD video. Okay, not even 4K, just standard HD video. And we can look at how large would a file be and how long would it take, what kind of bandwidth would it take to stream a video made out of sequences of these types of images. One more thing I've got here. I'll just keep this up for reference. This is some unit conversions and typical storage sizes and file sizes and internet speeds. And this is just so you can kind of have this to look at while I'm doing the arithmetic on the calculator. So let me go ahead and get out of the way and pull this up. All right, so let's start out with the question of storing video on our computer or other kind of device. And so we'll look at the PNG file first, which this is actually compressed somewhat, or quite a bit. But so let's think about if we made I'm going to do a typical episode of this TV show about an hour, and I'm going to try to think of the file size of, and that an hour video would be if I were doing 30 frames of this image per second. So the PNG file size is 1.9 megabytes. So I'll go over the calculator, and I'm putting 1.9. And we said there's 30 frames per second. Means already we are at 57 megabytes for a second of video. And obviously that's getting big very, very quickly, but let's times it by 60. So now we're at a minute. This is megabytes for a minute of video, and I'll times it by 60 again, and we are at an hour of video. All right, so 205 megabytes for an hour of video. When we look at the typical storage capacities, one of the things you'll notice here is, we don't measure device storage in megabytes typically anymore. It's always gigabytes or maybe even terabytes. And so this number isn't necessarily meaningful to me in deciding how much storage space I need. So we can go here, and if I am in megabytes and I want to go to convert it to the next unit up, which is gigabytes, right? There are 1,024 megabytes in a gigabyte. So I am just going to come over here and divide by 1,024. And what I found out is that I need about 200 megabytes to do just an hour of consecutive PNG images. And clearly you can see that it's no good for a DVD, won't fit on a Blu-ray, might fit on one of the more expensive micro SD cards, but you're only getting 1 hour of video on there. And even on something like a top-end phone, right, you are not getting, an hour of video probably won't fit by the time you consider all of the other pictures and apps and things like that you have on your phone. And, even if you went to a hard drive, it would fill up very quickly if you were trying to store video on your hard drive. So consecutive PNG images is not the way to go. All right, so I'm going to trash this. And let's explore the same math with the JPEG images. So the JPEG image here is 285 kilobytes. So let's do 285. And there are going to be 30 frames per second. Right, so we're 8,000 kilobytes for a second of music, and we'll go times 60 for minutes, times 60 again for hours. And so an hour episode using consecutive JPEG images is about 30 million kilobytes. Okay. Again, this is This is not really a meaningful number to me because it's not in the same unit that my storage would be. So if I am in kilobytes, if I divide by 1024, I've turned it to megabytes. And if I divide by 1024 again, I am in gigabytes. Right, so now an hour's worth of consecutive JPEG images, we're at about 29 gigabytes. And so it'll fit on some Blu-ray discs. And remember, this is an hour, not a 2 hour or more feature length movie. So you can probably see we have another problem there. And even if you're trying to put it on a micro SD card or on your phone, you can see that it would fill up very, very quickly. And even a hard drive would fill up really quickly. So as far as just storing the movie, consecutive images is not really going to work. Okay, even though the images are compressed, there's still something else maybe that we need to do if we want to store them. All right, so let's forget about storing them now, and maybe consider, all right, I don't have room on my device to store it, but at least maybe I can stream it. And can I do that? So I'm not even going to deal with the PNG. I figure that's obviously out of the question. That was way too much. We'll just stick with the JPEG images. And so there are 285 kilobytes in a JPEG. And I'm going to go down here and look at internet speeds. And internet speeds are typically measured in bits per second, okay? And megabits per second is million bits per second. So like your phone has an internet speed of probably, hovers around 12 megabits per second. And your home internet is going to be faster than that, but, so maybe 20 or 100, or you might have 200 or 300 megabit per second internet at home even. All right. So this number right here is in kilobytes, right? That's my image. And my internet is measured in bits. So what I'm going to do is take this kilobyte and I'm going to times it by 1024. And so this is kilobytes. And if I times it by 1024, I have turned it into bytes. Okay. And now we've got to turn it to bits. So there are 8 bits in a byte. So I'll times it by 8. And this is how many bits make up a frame, a single JPG frame of video. And I can look at this and already, right? It's 2 million bits for a frame of video, and I can only get 12 million per second. So you can see I can't keep up with like something like a phone or a DSL connection. But let's just go ahead and times that by 30 for the sake of getting a bigger number out of here. So this is 1 second of music. And now it's obvious that streaming consecutive JPG images for video, well, there's no way you could do it on your phone. There's no way you could do it on a DSL connection. And maybe you could pull it off on a really good home internet connection. But if you are streaming 7 million bits per second for a couple hours, one is nobody else in the house with you better be doing anything on the internet at the same time, and also your ISP is not going to be happy. All right, so I'm going to leave it there. So, I think at this point it should be obvious why video compression is necessary. And as for how video compression works, I'm going to link over to Tom Scott's video on the subject because he is going to do a far better job than I at explaining that.